Okay, in this part of the lesson, we're going to look at how to graph quadratic inequalities. Just like linear inequalities, we need to first graph the boundary of the quadratic inequality. So if we take the first inequality here, we could first rewrite that with an equal sign. Then we can find the line of symmetry. That happens to be 1, negative 1. Now we can find the minimum point. I know it's a minimum because A here is a positive. And this will be negative 14. So now we have a vertex of negative 1, negative 14. So now I can begin graphing. So I just drew in the axis of symmetry where x equals negative 1. And I'm going to plot the vertex of negative 1, negative 14. And then my y-intercept is negative 5. So it's about here. And the reflecting point would be the distance from this point to this point's 1, so it should be here. So this should be negative 2, negative 5. And then because this is a greater than sign, it has to be a dashed boundary, parabolic boundary. This is supposed to be curved. Okay, I'm not going to shade anything yet. I'm going to draw the other parabolic boundary. So x equals to negative 2 over 2 times negative 1 is 1. And this will come out to be 4. So our vertex is at 1, 4. Y-intercept of 0, 3. I'm going to draw the line. The axis of symmetry is at x equal to 1. Okay, and then the vertex 1, 4. And y-intercept at 3. It's right here. So this is 0, 3. And then reflecting point is here. That's 1, 2, 2, 3. Go ahead and graph this. Okay, this is less than or equal to, so we need a solid boundary. Don't worry about where they intersect. Just do your best to graph these parabolas to the best of your ability. Okay, now it's time for shading. And for the parabola in blue, I am going to test 0, 0. And 0, 0 happens to be a solution, so we need to shade this way. And let's test 0, 0 for this one. Yes, and this is a true statement, so we're going to have the shade. Downwards. So the intersecting region will be your solution. Okay, let's look at how to solve this inequality algebraically. So we can first factor out the negative sign. And then we can divide both sides by -1. And when we do that, the inequality needs to change direction. Now we can factor. This happens to be 5 and 10. And we can use a number line to test some points here. So 5 is here, and 10 is here. And then the zeros are 5 and 10. But since this is a less than sign, we don't want 5, we don't want 10. And we need x values that will satisfy this entire inequality. So I'm going to test, make a chart here. So I'm going to first test the number 6. And when I get 6, that would be -4. So I know 5 will be 0, 10 will be 0. Great, -4. Exactly, that's less than 0. Okay? And if I just want to double check, what if I put 4 here? So 4 minus 5 gives me -1, 4 minus 10 gives me -6. So that makes a +6. But +6 is not less than 0, it's greater than 0. So we don't want this, we want something that's less than 0. So when you get 4 here, you get a positive number. We don't want that. So we want everything between 5 and 10. So our solution would be 5 less than x less than 10. Well, that's how we present our answer when it asks you to solve an inequality algebraically. And to solve an inequality graphically, okay, I'm going to draw the y-axis here so that I can give myself more space. So from the original inequality, we know that the axis of symmetry is (7.5). 1, 2, 3, 4, 5, 6, 7. And then when we find the vertex, let's see, 7.5, oh, forgot the square here. Square plus 15 times 7.5 minus 50. This should give us -56.25 plus 112.5 minus 50, and this should be 6.25. And from the chart earlier, I know that my zeros are 5 and 10. So if this was 7, this would be 5, 7, 8, 9, 10. So my vertex right here, and go ahead and graph this. Okay, and again, remember these are dashed. Okay. Okay, looking at our graph here, we don't want to include 5 and 10. Okay, and if we sub 0 in, then this would be negative 50. My apologies, this original quadratic function should be greater than 0. So this would be negative 50 greater than 0, but this is not true. We don't, 0, 0 is not a solution. So we need a shade on the inside. But we cannot shade below the x-axis because the graph of the x-axis would be y equal to 0, right? Because of the fact that this entire inequality here, this quadratic inequality, is greater than 0. Okay? This 0 means when y equals to 0 and the graph of that is here. And we want all the points above it. We don't want any points below. If we were to put a 4 here, we would get a negative y value. And here, we could let this be y equal to this entire quadratic function. This entire quadratic function is greater than 0. We can't have a negative y value. Okay? So then we can just present our solution as everything between x and 10. Okay, we'll look at a different situation where we have this inequality here. Negative x squared minus 2x minus 1 less greater than 2. Okay, I'm going to write this as a quadratic equation and rewrite it so that it's set equal to 0. And I'm going to try to find I'm going to find the axis of symmetry. So axis of symmetry is at x equals negative 1. And then if we plug negative 1 in to find the maximum value, we would get a negative 2. So our vertex would be at negative 1, negative 2. And our y-intercept would be at negative 3. I'm going to reflect this point. So this would be negative 2, negative 3. As you can see, after we graph this dash parabolic path and do the shading, and put 0, test the zeros. So 0, 0 is not a solution, so we should shade on the inside. However, this is not the solution, because if you look at the quadratic inequality, we want everything that's greater than 0. Okay, I move the 2 over so it becomes negative 3. So we want this part. We want everything to be y greater than 0, but all your solutions are down here. Therefore, we have to write no solution. Okay, when we look at this example here, you may notice that this is not factorable. Okay, so if I move see, negative 3x squared plus 4x, and I move the positive 2 over to the left-hand side. This becomes minus 7. And we're going to factor out the negative sign. So if you think about factoring this, we can't really find pairs of factors in which we can rewrite this as a product of two binomials. So we must resort to graphing. So I'm going to take this inequality again and put it down here and rewrite it as a quadratic equation and set it equal to 0. So my vertex will be negative 4 over 2 times negative 3. So this will be 2/3. And then when I went to find see if this is negative 3, then it's going to be a maximum value. And when I substitute in 2/3 into the quadratic equation, I would get negative 5 2/3. You can double check to see if this is correct. I actually worked this out, so it should be correct. So our vertex would be at 2/3, negative 5 2/3. So I'm going to roughly graph this. This were 1, this would be about 2/3. Negative 1, negative 2, negative 3, negative 4, negative 5. Then 2/3 about, negative 5 2/3 about here. So my vertex will be here. And then if we look at this quadratic equation again, our y-intercept will be here at 0, negative 7. And then axis of symmetry at x equals 2/3. So I need to reflect this black 0, negative 7 point 2/3 to the right from the axis of symmetry. So it's about here. So this would be 1 and 1/3. So we would have negative 7, 1 and 1/3. Because this would be 1/3 and this would be 1/3, so 2/3. And because this is a less than or equal sign, our boundary should be solid. Okay, now we need to look back at the quadratic inequality. Let's refer to this one because we want to set it to less than or equal to 0. So this part could be considered y. In other words, we could look at this as y less than or equal to 0. Now let's test our points here. I'm going to test the 0, 0 point. 0, 0, minus 7, and it produces a true statement because 0 will be, negative 7 will be less than or equal to 0. So that's a true statement. So we would shade everything up here. However, I am not to shade anything above the graph of y equals 0 because we want all y values less than or equal to 0. So in this case, we would take all the x coordinates to be your solutions. So we would say your answer will be all real numbers. And if we look at the example from before, okay, let me rewrite this inequality as negative x squared minus 2x minus 3 greater than 0. So this means we want all the y values greater than 0. But all your solutions are down here, so we don't have any y values that are greater than 0. So again, that's why we have no solution. And once again, you look at this one, all these solutions have x values that satisfy the inequality y less than or equal to 0. And remember, we have to let this part equal to the y here. Okay? Okay, for this problem, the area A of the region bounded by a parabola and a horizontal line is given by this formula. Area equals 2/3 base times height. So if we look at this picture here, so we just take 2/3 and we find the length of this base and we multiply by its height, which happens to be from the maximum to its base here. And here it says where B and H are as defined in the diagram. Now, find the area of the region determined by each pair of inequalities. So it's actually just this pair of inequalities. Please change the 3 to 7 so it will be easier to work with. And the first thing I did for you was to graph the second inequality, y less than or equal to 7. I first graphed the boundary line for you already, so that's y equal to 7. I am not going to do any shading yet. Okay, and then secondly, I took the inequality here, the quadratic inequality, and set it to an equation. And that would be y equal to x squared minus 4x minus 5 here. And then I went ahead and found the axis of symmetry to be 2. So here I plotted it, and then I drew a line. And then y, I look for the y, which is in this case, this has to be, since this is a positive here, this will be a minimum value. So it's just the opposite of this picture we have here. Okay, so the minimum value came out to be -9. So our vertex would be 2, -9, which I plotted for you here. And then I looked for my y-intercept. My y-intercept would just be 0, -5. Okay, and then I found the reflecting point of 4, -5. And then to make this graph even more precise, I can find the zeros. So I went ahead and took the quadratic equation, y equals x squared minus 4x minus 5, and I factored it and then set it equal to 0. And then my zeros will be at -1 and 5. And then since there are two functions going on here, I actually can find the point of intersection. So here I have it written for you. I'm going to take these two functions and set it equal to each other. And then we can go ahead and factor these. And then this will make 6 and 2. So again, our intersecting points will be at x equals -2 and 6. So when x is -2, y will be 7. I'm just being very precise here. Okay, and when x is 6, this would be 7. And now I'm ready to connect my dots very precisely. Okay, now that I have that established, I can shade. Okay, so when we shade y less than or equal to 7, it would be this way. And when we shade the parabola, let's test 0, 0. 0, 0, minus 5, so y will be greater than or equal. So that's true. So we would shade, it means a different color. Let's use blue. Shade the inside. So the shaded region would be from this area. So the base will be the distance from this point to this point. So since we know that it's -2 here and 6, we can take 6 minus 2, so we know the base is 8. And the height will be from, this would be 2, 7. So we could take -9 units, okay, or we could take 7, actually. 7 minus 9, so that'd be 16 units. And this will be your height. So to find your area, it's be 2/3 times 8 times 16. And this will make 256/3. And this will be your answer, okay, the area of the shaded region.